talk about it. Let me say two things. One, let me comment about hers that that you can rewrite these things to double check her bound, for example, which is a really neat formula to know, is that 1 over 3 to the n, if I wanted to go back to sum equals 0 to infinity, then I just have 1/3 to the what? N plus 2, right? What's the first term here? It's 1 over 3 squared. So if I want to start at 0, if I just change my index to 2, what do I have? 1/3 to the n plus 2. Because now the 0th term will be 1/3 squared, just like that. So that's sum from n equals 0 to infinity. Just trying to get you to where you can manipulate them. 1/3 squared, 1/3 to the n. It's kind of hard to read. 1/3 squared. Right? 1/3 squared times 1/3. Break that into two pieces. Factor the constant to the outside of the series. There's my 1/9. There's my 1 over 1 minus 1/3. Notice that's what she wrote right there. So it's two slick ways that I've shown you before to figure out your bounds when they don't start at 0. One is to go ahead and subtract off the first couple of terms. Do it from 0 to infinity and then subtract off the first few terms. The other is that slick trick of just throw the first term on top. Okay. Now, as far as yours goes, Andrea, remember that we have, based on this P-series test, what's that equal to? Anybody? Diverges, right? Because that's a P-series with what? P equal to 1. And Mark showed us that it diverges when P is equal to 1. Also popularly referred to as the harmonic series. Right? So that diverges. So once you know this fellow diverges, notice, Andrea, that the terms do go to 0, right? The limit as n goes to infinity of 1 over n is 0, but it does not converge. So the terms going to 0 are not enough to guarantee that it converges.
Because there is a p there, it doesn't.
Pardon?
There is a p there, it just means 1 because it doesn't.
Yep.
You have to consider it.
Yep. Okay. There's only 2 minutes left. I'm gonna pull rank tomorrow. I want to talk about the limit comparison test. That's going to take a little bit of time. I don't want to try it. It's not one of those things I want to squeeze in the last 5 minutes and try to make sense of. It's kind of one of the more challenging ones. So I'm going to pull rank tomorrow and actually earn my pay. I'll talk more about the direct comparison test because you can do that one in the back, but you should try 289 to make sense of the first half of my lecture tomorrow. Write out some of the terms. Write out some of the terms of that fella and see why does it converge. You can't compare it to this, right? Because this is not less than this. But you can compare it to this if you just write out some terms here and write out some terms here and see what you can learn. Play with these two.
Can you make the bottom negative?
Pardon?
Can you make the 130 n negative?
I don't understand the question, Dominique.
Can we put it negative just to play with it?
I still don't understand the question.
Changing your b n to negative 1/3 n is what he's talking about.
At the bottom again.
Negative 130?
He's just talking about comparing.
So compare,
like,
can you make it?
Well, you can pick anything you want to compare it to, but if you think this converges, you got to find something that's smaller than it. Right. That it's smaller than. You think this converges, and you've got to get it less than something that converges. So you've got to find something that converges. We know this converges, but you're going to have trouble showing this one's less than this. But if you shift the index a little bit, you can. So the clue is kind of like we shifted the index up here. There's a way to play with this one to shift the index to show that if I just mess with the index a little bit, I can get this bounded by something. Or maybe throw away the first few terms of this one. There's a clever way to do it. I'll talk about it tomorrow, and then I'll talk about the limit comparison test. All right, stay off the streets.